Good. Dear distinguished participants, thank you very much for joining us for this Global Networking Forum. Welcome to this Global Networking Forum, Chang'e Lunar Sample Scientific Research. This is the IAF World Space Prize 2025, which was awarded to the Chinese Chang'e 6 mission team for their achievements in returning samples from the far side of the moon. This award is one of the most prestigious of the International Astronautical Federation and recognizes the exceptional impact of a contribution in space science, technology, medicine, law, and management. And many of you have actually witnessed when the award was presented during the opening ceremony here in Sydney. Today's World Space Award lecture will be given by Mr. Guan. He's the director of the Lunar Exploration and Space Engineering Center from CNSA, the China National Space Administration. Please come upstairs. And I just want to say, as you have seen, there are very precious samples which you probably will never see or have not seen before. After the lecture, you can come close and have a look. Yeah? Thank you very much. Please.
Thank you, Mrs. Pascal. Distinguished colleagues, ladies and gentlemen, good noon. My presentation today has 4 pillars. Review of the Chang'e 5 and Chang'e 6 missions. Research on lunar samples, international applications for Chang'e lunar samples, and international exhibitions of Chang'e lunar samples. Next. This is Chang'e 5 mission. From launch to sample return, it took 24 days. And this is Chang'e 6 mission. From launch to sample returns, it took 53 days, achieving the world's first sample collection and return from the far side of the moon. After lunar samples were returned, we successively completed operations such as sample unpacking, screening, and sub-packaging. 3 days of the lunar scientific research samples were prepared for scientific research use. At present, lunar scientific research mainly focuses on the following important scientific issues: the verification of the hypothesis on the origin of the moon's dichotomy, further research on the history of lunar volcanic activity, the evolution history of the magnetic field, and the history of lunar impact. Research on Chang'e lunar samples have provided new discoveries and insights for these issues. Previous studies have shown that there are huge differences between the near and far side of the moon in terms of volcanic activity, crustal thickness, rock types, and the enrichment degree of crib materials. Based on this, a hypothesis on the origin of the moon's dichotomy was proposed. Research on the far side sample of Chang'e 6 has provided new supporting evidence for this hypothesis. Through the analysis of isotopes and the calculation of oxygen fugacity of the far side sample of Chang'e 6, by comparing with the Chang'e 5 samples collected from the near side of the moon, we found that the mantle south region of the basalt in the far side sample of the moon has the characteristic of low water content no enrichment of creep materials, and low oxygen fugacity, which provides new evidence for the genetic mechanism of the dichotomy. It is generally believed that lunar volcanic activity began 4.4 billion years ago, was active between approximately 3.9 and 3 billion years ago, filled a large number of lunar basins, and roughly formed the current lunar mare pattern. Volcanic activity began to decline between approximately 3 billion and 1 billion years ago, and there has been basically no volcanic eruption since about 1 billion years ago. So the moon is considered geologically dead. Through lead isotope dating of Chang'e 6 samples, 2 phases of basalt were found, which are 2.8 billion years old and 4.2 billion years old, respectively. This is the first time that volcanic activity has been found to exist in these periods, revealing the history of volcanic activity on the far side of the moon. The basalt of the Chang'e 5 sample is 2 billion years old, which is the youngest basalt on the moon. At the same time, we found 3 pieces of volcanic glass with an age of 120 million years in the Chang'e 5 samples. This means that during the late Cretaceous period on Earth, there was still a certain degree of volcanic activity on the moon. This discovery is of great significance, as it reshapes the primary framework of lunar evolution, reveals the lasting vitality of the moon, and provides new clues for lunar volcanic activity and the thermal driving mechanism. Previous studies believe that the evolution of the lunar magnetic field mainly went through the following processes. The magnetic field was active from 4.2 to 3.5 billion years ago, reaching a peak between 3.8 and 3.5 billion years ago. The magnetic field intensity decreased by an order of magnitude for the first time about 3.1 billion years ago, and maintained a low magnetic field of several microtesla. The second decrease occurred about 1.5 and 1 billion years ago. Finally, it completely disappeared at some time after 1 billion years ago. Research on Chang'e 5 samples found that there was a weak magnetic field on the moon at 2 billion years ago, which is consistent with previous conclusions. However, the telomagnetic information of the far side obtained by Chang'e 6 shows that the lunar magnetic field rebounded and strengthened at 2.8 billion years ago. This greatly changes the evolution history of the lunar magnetic field, indicating that there are still great uncertainties in the current lunar magma ocean model and lunar core dynamic model. At the same time, it provides a new key anchor point for the research on the lunar magnetic field, indicating that the moon has more complex internal dynamic processes. The landing area of the Chang'e 6 is located the northeast of the South Pole Arctic Basin. The SPA Basin is the largest non-impact crater in the solar system, and also the deepest and oldest impact basin. The SPA basin is of great research significance. The formation time of the SPA basin can provide a key anchor point for improving the impact history of the solar system. The large impact excavated deep mantle materials revealing the internal magmatic activity of the Moon. At the same time, the large impact event may be closely related to the lunar dichotomy and the loss of lunar volatile materials. A new rock type, SPA norite, was found in the Chang'e 6 samples. This rock type has not been found in the lunar rockers collected by humans before. Based on the analysis of SPANS, the formation time of the SPA basin was determined to be 4.25 billion years ago for the first time. The Apollo Basin is located in the northeast of the SPA basin with a diameter of about 540 kilometers. Through the analysis of Chang'e 6 samples, it was determined that the Apollo Basin was found about 4.16 billion years ago. This study is of great significance for analyzing the impact history of the inner solar system. The sulfur isotopes in the Chang'e 6 sample are basically consistent with those of the samples from the near side of the Moon, and the sulfur isotopes inside the Moon are homogeneous. At the same time, they are about 0.002% heavier than the Earth's mantle. This phenomenon may be caused by the global evaporation of volatile materials due to the giant impact event during the formation of the Moon, which supports the giant impact hypothesis for lunar origin. The olivine found in Chang'e 6 has an extremely high FO value and nickel content, and its chemical composition is very similar to the first batch of olivine crystallized from the magma ocean. It is believed that the impact event that formed the SPA basin enabled the magnesium-rich magma to erupt in this area, and the mantle-derived olivine was carried and ejected to the lunar surface. The first discovery of the mantle olivine this time will provide new evidence and a theoretical basis for determining the composition of the lunar mantle and understanding the formation and the early differentiation processes of the Moon. Space weathering includes impacts of meteorites and macrometeorites, as well as irradiation by solar wind and cosmic rays, which cause significant changes in the chemical composition and the structural characteristics of the lunar solid surface. For example, impact caused the lunar rock to break and melt, forming finer-grained particles and sediments. By comparing the Chang'e 6 samples and the Chang'e 5 samples, we found that also the exposure time of the far-side sample of the Moon is shorter. The intensity of space weathering they suffered is higher. The difference in the intensity of space weathering between the near and far side of the Moon also provides theoretical support for the hypothesis on the origin of the lunar dichotomy. Lunar water usually exists in the lunar soil in the form of mercurous water or hydroxyl or water ice, with an abundance of approximately 10 to 1,000 ppm. The main source of lunar water are asteroid, comet impacts, and volcanic outgassing or hydrogen ion injection by solar wind and radiation. The research results of Chang'e 5 confirmed for the first time that impact glass is an important water reservoir in the lunar soil. The research results of Chang'e 6 showed that basaltic glass is more water-rich than plagioclase glass. It was found that brown mineralite in the Chang'e 6 sample is widely present at the phase interface between mantle particles and impact glasses. It is inferred that the formation regions of brown mineralite are roughly divided into two types. It may be produced by large impacts caused by sulfur-rich impactors, or it may be produced by excavation and thermal events on the scale of impacts reaching the sulfur-rich mantle core boundary of the Moon. Regardless of the formation mechanism, this indicates the diversity of the source of the Chang'e 6 lunar soil and the complexity of the thermal environment. The analysis of polycyclic aromatic organic matter in the Chang'e 5 lunar soil shows that it is a complex organic matter with the highest known content in the lunar soil. This study provides a new perspective for the research on lunar organic matter and helps to understand the accumulation processes of lunar organic carbon. The existence of neutral few-layer graphene in lunar samples was confirmed for the first time, and its structural and compositional characteristics were clarified, which suppose the hypothesis that a carbon cycle may exist on the Moon. It brings new direction for lunar research and graphene research, and provides new ideas for the low-cost and large-scale preparation of high-quality graphene. By heating, melting, cooling, and drawing the Chang'e 5 sample into fibers, the lunar soil fibers were successfully completed. These fibers have excellent mechanical properties and broad application scenario in protecting against the extreme environment on the lunar surface, providing a guarantee for innovative material technology with high reliability, lightweight, and environmental adaptability for future lunar exploration. So, the above are all the results produced by scientists through the research on Chang'e lunar samples. I just summarized some of the contents and would like to take this opportunity to introduce them to you as representatives. The China National Space Administration announced that the opening of the international loan application for Chang'e 5 lunar sample at the 74th International Astronautical Congress. We received applications from 24 scientific research institutions in 11 countries. After review, The sample application from 7 scientific research institutions in 6 countries were approved, including the United Kingdom, France, Germany, Japan, Pakistan, and the United States. On this year's China Space Day, representatives of scientific research institutions from 5 countries, including the United Kingdom, France, Germany, Japan, and Pakistan, signed the lunar sample loan agreements with the Lunar Exploration and Space Engineering Center, and then received the lunar sample. At present, Stony Brook University in New York State, the United States, has signed the sample loan agreements and will come to China to receive the lunar soil in the future. Brown University in the United States has not yet signed the sample loan agreement with us. We will soon open the second round of the international loan applications for Chang'e 5 lunar sample. Scientists who are interested in this are welcome to log in to the link on the website of the CNSA provided on the screen, or directly or log in to the application web page. Fill in the application form and submit the application materials in accordance with the application guidelines and operation manual provided on the web page. It is hoped that scientists around the world will use the lunar sample from China Chang'e project to discover more materials. In the past 2 years, the Chang'e 5 and the Chang'e 6 lunar samples have been exhibited internationally many times. At the CNSA booth of this International Astronautical Congress, the Chang'e 5 and the Chang'e 6 lunar sample, this special is lunar rocket, are also on display. You are welcome to visit and communicate at booth of the CNSA. So thank you all. Okay.
Thank you very much, Mr. Gon, and congratulations again for your prize and the announcement that samples you can apply for new samples. We have a lunch break now, and we have to clear the room, but I ask you kindly, if you are interested to speak to the team briefly or want to see the samples, please come forward and see these exceptional samples from Chang'e 5 and 6. Yeah? Thank you very much.